All right, ladies and gentlemen, welcome to the fourth video for Honors Prep and the third and final video for regular geometry. In this video, we are going to discuss how to graph circles on the coordinate plane from standard form. So, again, when we are in standard form, we are talking about being in the format x minus h quantity squared, y minus k quantity squared equals r squared, where the center of our circle is the point HK, and the radius of our circle is R. So, the first example here is in standard form. Notice everything matches up. We have x minus h squared, we have y minus k squared, and we have r squared. So look at what we got there. Notice that the equation says -4, but h is actually +4. It is the opposite. H and k are always, for this particular skill, the opposite of what's written in the equation. So when this says x minus 4, that means h is +4. Same for k. This says y plus 1, so k is -1. And then right here, this 9 tells us that r squared equals 9. So our center is located at the point 4, -1. And to get the radius, we need to take the square root of 9, which gives us our radius is 3 units. So we pull that equation, or that information from the equation. Then we travel over to our coordinate plane. I'm going to make it a little bit bigger because I have plenty of room to do so. Okay. We graph the center. The center is the point 4, -1, which is right 4 and down 1 from the origin. So we graph the point HK. And then what we do is from that point, we travel the radius in all 4 directions. We go up 3, put a point. Go right 3, put a point. Go down 3, put a point, and go left 3, put a point. All 4 of those points are on the circle, and then we do the best that we can to freehand a circular graph through those 4 points. Again, the key is those 4 points are indicated means that you have graphed the circle correctly, even if your curve is not very round. Because, humans can't draw a circle perfectly by hand. We have to work with what we've got. So, in the second example here, this one is not quite in standard form yet. So we need to think, okay? We've already got x squared, we've already got y squared, but what we don't have is this number is in the wrong place. We need to move it to the other side of the equation first thing. That puts this equation into standard form. So x squared plus y squared equals 4. Now notice that there's no numbers attached to x and y. Think back to the examples we did earlier. What that's telling us is that what we really have here is x minus 0 quantity squared plus y minus 0 quantity squared equals 4. Again, that is our format. Okay, that's in the correct format now. X minus h quantity squared, y minus k quantity squared equals r squared. So that tells us h is 0, k is 0, and r squared equals 4. So that means our center is located at the point 0, 0, which is the origin, and our radius is the square root of 4, or 2 units. So again, we go over to our graph. We graph our center, which is the origin. And then we travel out in all 4 cardinal directions, 2 units. And we place a point. 2 units above the center, 2 units to the right of the center, 2 units below the center, and 2 units to the left of the center. And then we do our best to draw a circular graph through those points. Okay, so I want you to pause the video and try the 2 examples on the next page. Regular geometry, when I change the page here, you're going to see an equation you're not comfortable with. That's because I only want to have to record this one time. So I'm going to record the pre-AP version of it. I will tell you in that example when we get to the regular geometry version of the problem. Okay? So pause the video and try the next two examples, and then resume the video and see how you did. Okay, so in the first example here, it is already in standard form. Remember that if there's no number attached to x, that means there's really a 0 there that is not written. So when we look at this, we have x minus 0 quantity squared plus y plus 1 quantity squared equals 4. That is in standard form, which means h is 0, k is the opposite of positive 1, which would be negative 1, and r squared equals 4. So our center is located at the point 0, negative 1, and our radius is the square root of 4, or 2 units. So we go to our graph, and make it a little bit bigger, because again I have plenty of room. We graph the point 0, negative 1, the center, which is down 1 from the origin. And then we move out 2 units, because that's our radius, in each of our cardinal directions. 2 units to the right, 2 units down, 2 units up, 2 units to the left. And we graph a circular curve through those 4 points. Okay, now as mentioned, this next example here is a pre-AP specific example, but on the geometry notes, the regular geometry notes, I have already converted this equation into standard form for you. So pre-AP students, honors prep students, we should know that we need to take that equation and convert it into standard form. Using our completing the square method. So again, that would be x plus 2, quantity squared, divided by 2. Square that is 4, which goes in the same first blank over there, plus y minus 4, because negative 8 divided by 2. Square that is 16. Add those up, that equals 16. So geometry students, you should recognize this equation because it's the one on your notes, because that is the same equation written in standard form. So from there, we do what we've done before. Now that it's in standard form, we're going to identify h, k, and r using the fact that we have written it in standard form. So h is negative 2, k is positive 4, and r squared is 16. This tells us that our center is located at the point negative 2, 4, and our radius is the square root of 16, or 4 units. So, as mentioned before, we graph the center first. Negative 2, 4 is left 2 and up 4 from the origin. And then from that point, we travel out r units, or 4 units, in each of our cardinal directions. 4 units to the right, 4 units up, 4 units to the left, and 4 units down from our center. Then we do the best that we can to draw a circular, oh, that's not very good, let's try that again. The best that we can to draw a circular arc through those points. As long as those 4 points are correctly placed, our answer is going to be correct. So there you have it, folks. That does it for section 10.8. Thank you very much for your time and attention.